Yeah, so the first section we are not doing. We are doing from row reduction. So let us see what they are talking about here, right? So you have this n by n matrix, okay, A. Left multiplication by an n by n matrix A on n by p. So this x you see, this is n by p, okay. And this they are saying you're computing it in this way, right? So do you understand this thing? So let me just explain this thing, and wait, let me see what else is there. Yeah, so basically they are mentioning the different types of reductions, right? So there are also three types of elementary matrices. They are obtained by doing this. They are shown below with yeah. So there are these elementary matrices and their effect. Okay, so I think I'll explain this like that on the board. And then there's a sequence of operations, and then you do this, and then you end up with this. Okay. All right. So let me explain this.
Actually, there is like one geometric something in the addiction that I have. I'm not sure why I'm not able to see this here. Like there is one picture as well.
Okay. Right. So you can tell me what it is about.
Yeah, sure.
So before that, let me just tell you what they are saying so far. Okay, then you can ready that. So you see, this is going to be a very important interpretation of matrix multiplication. Okay, so guys should follow this. So
Okay.
uh, rather than calling it row reduction, yes, you do use it. I would say that you do use it to understand row reduction. Row reduction is like a way to simplify a system of equations, but you understand it in terms of matrix multiplication, and that comes via this interpretation. So let me first say this interpretation. Okay. Yeah. And I've seen this being used in many problems, but for now you can just follow it just like that. Suppose it's an n cross m matrix A, okay, and B is another matrix, and so this has to be something like this. So we are going to look at the product, right? And now,
Okay.
of course, yeah, all of us know
N cross
what,
B.
right, it's n cross p. And if I just say this is n cross p, now all of us know this, that what is the ijth entry of this, right? The
Yeah.
ijth entry of this, you already know in
Summation.
words, but exactly, but I'll just write it. So, uh, yeah, I'll write it abstractly. We should try to digest it. Ik and okay. Let's follow the style. This may be a little different from how it is mentioned in the books, maybe, but you should try to see it. This can be useful. You see, this way of writing this, and here the k will run, right? So the
One
yeah, from where to where? Anyone quick?
from
So 1 to m, right?
Yeah, exactly. That's the only thing, right? It's the only thing that's possible. Yeah. So all of us know this. Yeah. Arnab, is this notation okay?
Yes, okay.
Right? So right. So this is the you can say the rule of matrix multiplication. Yeah. But we are not going to interpret it like this. Okay. Our goal is to understand this matrix C, okay, which is the product, but row wise. We want to understand the rows. We want to understand the matrix C, but not element wise, but row wise. We want to, so I would say we want to understand the rows of C. Okay. You can think of it like that, then it's good. Okay. We this will be very useful, especially when you do linear, more abstract linear algebra, which is yeah. We want to understand rows of C. Okay. Understand the rows of C. C is I could just so now I will stop writing the subscripts because I understood. If anything in mathematics is understood by all, then we don't write it. Right? That's how mathematics progresses, right? You can think like that. So we want to understand the rows of C. So Yeah, maybe it's just you can start drawing picture. So let us say you look at the first row. Okay. So yeah, anyone can come forward and describe the first row of C. Any description?
So we're taking rows of A and one by one we're matching it up with elements from columns of B, and then we're multiplying and adding them based on the given rule. So what happens is the row one, it has 1 second, sir. Yeah, the first element, that is the elements that are A11, A21, they are multiplied with say the elements from B, and then that's what makes up your first row.
But that's that is okay.
Oh,
Yeah,
sorry, I
can-
meant A12. I meant A12, 13.
Yeah,
Can you
sorry.
please rephrase the question?
Yes. I'll say the answer. Okay. I mean,
Yeah.
but I mean, still, it's never completely answered, right? You can refine it. Okay. So what I will say, go ahead and say is following. Maybe I will call this R prime. Okay. Okay. So, and then there are other things, but look at R1 prime as a vector. First step.
Okay.
So first step, I'll write it. View R1 prime as a vector. View it as one entity, one thing.
Okay. Yeah.
Then you will see that, and this is simply to verify, is that R1 prime is so okay. Is this notation okay? Arnab,
Like,
can you
it's
say what
multiplied
this
with
means?
base, right? Okay, sorry.
Yeah, that's fine.
It
Arnab, do
says
you?
that the first element A11 is multiplied with the first row R1.
Yes, scalar multiplication of a number with a vector. Perfect, right? Yeah. You will work out
Or linear
examples.
combination, you can say.
Sorry,
Or as a linear combination, you're writing, right?
that I'm going to write, but I just asked what
Okay.
that thing means. Yeah, correct.
Okay,
So
okay.
then you already see it. The correct way to say it is yes, as linear combinations. Right, and that's the point. Linear combinations. Something wrong? Yes, it's M here. Yeah, you realize the wrong. Mathematics guides you itself. You don't have to worry so much most of the times. That's why you see a lot of people moving very fast, because actually they don't worry most of the things, because they know that it will be taken care of in the process. So yeah, but anyways, so you see basically what has happened is the first row of R1 prime is a linear combination of the rows of B, and the weights are coming from A. Okay, so everything is clear. For the first row, the weights are coming from the first row of A. For the second row of the product, weights are coming from second row of A, and so on. A proof, that's trivial. You can just write it and check it, right? There is nothing to prove.
Yeah.
You can
It
just
comes
do it.
directly from the matrix multiplication definition, right?
Right. Exactly.
Yeah.
But as a homework, you should write it and maybe show it to me. I want to see also how you write, how much repetitions you are making in writing. Okay. So please write a proof for homework. Not writing it on board, but you should write it.
Sure.
Okay. And you will keep using this all the time in your mathematical studies. Yeah. So we understand this interpretation. Okay. Very well. So yeah, maybe I can erase this. Yeah. Now, what is row reduction? So row reduction again can be motivated from all the things, and yeah, but system of equations. But let me not say it like that. Otherwise, let me just directly say what row reduction is. But yeah, before that, Rohan, did you find what picture you are talking about?
Yeah. The thing is, can I send the is there any way I can send a picture, because I have the physical book with me, so I
Okay.
couldn't find the picture in the
But you
PDF.
can describe what it means. That's important, right?
uh I wasn't able to completely comprehend. Like somehow they show it's sort of a vectorial graph, and when they apply the row reduction, then it sort of like scales down or something like that. Like that is the picture that I have in my mind.
Okay,
Uh,
it's for row reduction only.
I am.
You suppose
Can I
so?
verify it again?
No,
Like,
it is not for row reduction, I think. Yeah,
okay.
maybe you might be, I might be wrong, of course, but maybe you're talking about this picture.
Yes, I am talking about.
This is
Is
not
it
row
like
reduction.
functional determinants? Okay.
This is
Okay. My
might
bad.
be wrong, but
I don't know. In the book I am having, it's
no,
literally
this is
for the
no,
section of.
it's 1.4.3. It's in this section of determinants. It is, yeah, it is not in row reduction. So leave it. It's not in row reduction.
Okay.
Right. So now can anyone explain row reduction after this interpretation? Matrix multiplication. So how does this interpretation of matrix multiplication help us to understand row reduction? Okay. So what is row reduction? Row reduction is just starting with one matrix. It doesn't involve three matrices, right? It involves only one matrix, you can say, in some sense. Start with one matrix. Start with one matrix A, M cross N. Let's again think of it in terms of rows. Let's say it has R1, R2, Rn. Yeah. Please do that homework and please check it. Multiply matrices and check. You can never get good enough at multiplying matrices. Okay, because there are patterns after patterns, and yeah, there's enough things you could do it. You do it as much as possible. Practicing matrix multiplication is never a bad idea. Yeah, and if you do it mindfully and not exaggerating. Yeah. So this thing, right. So we take this and we want to do something with the rows. So what is it that we want to do something with the rows? You already know. I just tell you. So rule one. Why you want to do? Just treat it as a game. Yeah, you will understand later, if not already. So rule one is exchange Ri with Rj. Okay, where I and j are m rows, right? Right.
So, sorry to interrupt, but like interrupt. Like I just send you a picture. Like maybe check it. Like when you're
Okay.
if when it's possible. Yeah, I send you the picture from the book that I'm having, the same book, and the picture comes literally below the row reduction. Maybe it's a printing mistake or something, but I'm not sure. I'm not sure.
Okay,
Please check.
I'll check it. There's no, this picture is not for row reduction. Yeah.
Right. So it's a printing mistake.
I don't think. Yeah. Yeah. But you see, I can simply tell you what this picture means, right? There's nothing in this
Yeah.
picture. In the sense. What this picture is just saying is that you have a matrix A. So just look at it. Let's look at a 2 by 2 matrix. Okay. So
Okay.
again, we are slightly digressing, but just hold on, not a problem.
Sure.
So suppose you are looking at this matrix. Okay. So again, this is a concept. You view matrices as just static objects, matrices, but obviously matrices can also be seen as anyone functions, right? Matrices can be seen, obviously it's not some new thing I'm telling you, I suppose. Matrices are just functions from R2 to R2. Any problem?
No.
Yeah. Why? Because if you just input some vector, if you just input 1, 0, what do you get? In this matrix, you get 1, 3. Right? If you input 0, 1, you get 2, 4, and so on and so on. These functions have a lot of properties and so on, which if you don't know, you will know. But this is a function, right? So this matrix is a function from R2 to R2, right? So what this diagram is saying is this E1, which is 1, 0, this E1, 1, 0, this is the input. And here the output is also drawn in the same picture, right? This AE1 is the output, 1, 3. Fine?
Okay.
Yeah. AE1
Yeah.
is the output. Obviously, in this case, the matrix was something else. I mean, so in this case, it's 4, 1. So maybe I'll change the matrix 4, 1, and 1, 2, 3, 4, 2, 4. Yeah, correct. Right? You see, then it's fine. Everybody, very important diagram. It will help you to show eigenvalues, existence of eigenvalues, and fixed points, and so it's useful not just for visualizing, but it also can actually give you insight into what can be. So this too. And why is this point there? I mean, because the determinant gives you the area of this parallelogram, right? The determinant of this matrix gives you the area of this parallelogram. You'll see that. You probably already know that cross product.
Mm.
Yeah. So that's it. Is not much.
Yeah.
But it's very useful. You will see. Anyways, we come here. So yeah, quickly. Rule 2
So,
are
sir,
yes.
so the determinant, it sort of gives you this unit square, the 0, 1, 1, 0 square, like how it's being scaled, right? And if it's
Yes.
negative, if it's flipped, like that,
Yes.
Yes.
Yes. The determinant is, so when you the determinant is a function, right? Which if it's a 2 by 2 matrix, the determinant is a function which takes 2 vectors and gives you a number. For 3 by 3, it takes 3 vectors and gives you a number, right? What else does that? Area, right? When you give some vectors, then you make the appropriate figure, and the area also does the same thing. Determinant also does the same thing, and it turns out that these two are the same things. Okay, it's just that determinant is from a computation, but obviously you will see that if you. Yeah. It comes up in all sorts of things, but determinant is a very magnificent construction. So any Arnab, can you tell me rule 2? I mean, it could be rule 3 also. I don't know the order, but yeah. Any other things you do with rows of a matrix?
Sorry, I forgot.
Okay, no problem. So when you have a system of equations, then what do you do? So suppose so. I mean, take an example. You already know it. I mean, we have all done this actually in school, but just in a different language. Okay, so don't worry about it. Suppose you have this, right? And so what does this mean? This means it is something like x, 2, y, 3, z. Your teacher gave you is equal to 1.
Right, the
maybe.
constant.
Right. We just write the
The constant.
constants. Exactly. We don't
Right.
repeat the things. That's what
I mean the
mathematics. Right?
coefficients.
Exactly. We write the coefficients. We don't. And this ignore the 1, 2, 3 for this side for the time being. But you understand, right? This you have been already doing. And so if you see this, then what is your instinct? What would you do? You would exchange rows maybe for aesthetic purposes, right?
Right.
But you would also try to, let's say, you would try to eliminate this x. Arnab?
By adding.
Yeah. Yes. You understand.
Adding or subtracting with the multiplication of one row.
Exactly.
Another
Right.
row.
That's all. Right. That's all. That's correct. So you basically, and we are just replacing things by ing. So you just say that you replace ri. Suppose is the ith row. So you replace ri. This is a symbol. Replace ri with, you take ri and you add with it some constant of the some other row. That's it. It's the same thing. We just writing it in a
Okay.
clean way and abstract way with i's and j's and arbitrary n, but that's not a problem. We just have to write it. The rest of the things gets taken care by its own. And the third
So
one,
it's so this rule 2 is analogous to what we do when eliminating variables, while solving
exactly.
linear.
Right.
Right.
Exactly. It is
Yes.
that. It is just that. It is just that,
Yes.
but you are forced to say it in terms of rows. That's all. Yes. Yeah. And the third one is Ri, and you replace Ri with some constant times Ri. Okay, probably this one is unnecessary, it feels, but you can call that.
Array, can you please say array is replaced with
C times Ri, right? So you multiply
right,
a row
right,
with a
yeah.
constant. Yeah.
The
you do
entire row
that.
has to change. Yeah, exactly. Yeah.
Yes, yes.
Yeah, right. Yeah, I get it. I get
Right.
it.
Yeah.
Okay.
So these are the three rules, and I will say here that C is non-zero. C is non-zero. Yeah. So these are the three rules. These are the three rules, and we will, for the time being, we'll forget the system of equations. Keep things
Mhm.
simple. To keep things simple, we will forget the system of equations, and we will just try to interpret, think of these. So when you see these three rules, then what kind of questions come to your mind? Let's try to answer them, and then you can go back and read this section from the book. Okay, but think of it very cleanly. See, there are very few things which you have to actually know. Rest of things follow. So see, the first thing that comes if you are sort of a computer scientist kind of person, you would say that like these three rules, are these three rules independent? Right? So can you get some rule from the other two rules?
Mhm.
Anyone knows this?
So I was thinking, like, if in rule 2 we incorporate Ri going to C1 Ri plus C2 Rj, then rule 3 can be
No, don't change the rules. Don't change the rules. That's not. I mean,
then I
just change
didn't
the, yeah.
then I
But
didn't understand
then
the
then there is still something. There is still so you can, yeah. Can you exchange? So suppose you use rule 2 and rule 3 maybe. Can you get, so what you do is I'll just show it maybe through this example. Suppose you want to exchange rule 1 and row 1 and row 2, right? So what you can do maybe is you
Oh,
take
other than actually exchanging, maybe you can use a constant and
yes,
right.
something like that, right?
Okay.
So you do something like this. This is by using rule 2. Okay. So just focus on the first two rows. We don't need the other rows. So this is rule 2, right? So from here I'm applying the matrix is changing. Okay, we are just
Okay.
applying the rules and we are moving forward. Okay. We do this. Yeah, we replace the first row by R1 minus R2. Second row remains as it is. Now what to do?
Okay. Then you can add the other row to get back the
Right. Right. That's nice, right? So then you
right.
get this is again by applying rule 2. Just adding. I think, right, I have just applied rule 2, right? Just added this row with this row.
So which means it will become R1.
Yeah, correct. Yeah. Okay, just tell me if it's not correct. Yeah, this one, and then what do you do after this? You subtract, right? Subtract this row from the first row, and then you get minus R2 R1.
Do rule 3.
And then you do rule 3 is needed. You can't just apply rule 2, right? So you have to do this. So rule 2 is needed. So you apply rule 3. I'm not writing applying rule 3. I'm just saying. But yeah, you get, so you can effect the rule 1 by using this. Arnav, how do you feel about this? Fine.
Yes, fine.
Okay.
Yeah,
So
even
you
I
see,
feel like the rule 1 sort of was a feel, like it doesn't add that computation wasn't. I don't know. Maybe I'm wrong. Like the rule 1 kind of felt of more like a more like a like what you told it as an aesthetic thing. Like it
okay.
doesn't.
Right.
Yeah.
Yeah. It seems like that, right? I mean, I did not
Definitely,
remember.
yeah.
I also don't remember, but I was just saying something seems redundant. Obviously, I also know it, but yeah. So now you can try to maybe take this as homework. Can you get rule 3 from rule 1 and rule 2?
Oh, right.
Think of all that you can think in your. These are very important questions. Okay. At the end of the day, being comfortable with these things is very, very important. Okay? And you have to spend time with these things. Right. So, right. So we have understood. So this is what computer scientists, and they ask many more questions, which we will not ask right now. We're just sticking to the syllabus kind of. So the next thing is to because see, these rules are defined combinatorially. Can you create the effect of these rules? I'll explain this in mathematically, but first phrasally. Okay? Can you create the effect of these rules using matrix multiplication? This is where the interpretation, the previous interpretation will come in the picture. Okay, we'll use an example quickly. Okay, that will be, I think, otherwise it will get abstract. So, and you will see that that interpretation will be useful. So you understand what we are trying to do. Suppose we have this, and let's take any rule. Let's say rule 3 is, let's take rule 2. Okay, rule 2. So we apply rule 2. Rule 2 is like a bunch of rules because you have to, it depends on the constant c. But let's say constant is 1. Okay? Doesn't matter. And I, ing or whatever, you understand when I write it. So
Yeah.
I am doing, you understand what I'm doing. Maybe it's good to write it. So I'm doing this, right? Replacing the first row by adding the second row to the first row. This I did a combinatorial operation. Can I do this combinatorial operation by matrix multiplication? So what matrix should I multiply here to get to this? I go with that as a rule, but now I want to go there using algebra. Can algebra take me there?
Inverse, I don't know.
Quickly, anyone? From the
The
interpretation.
inverse?
No, you don't need inverse. It may
No,
not be
okay.
invertible. Yeah. Maybe this one is invertible, but yeah. The interpretation, use the interpretation. So, I mean, what have I done? I have taken combinations, right? So this one is a linear combination of this row and this row. Okay. First row of the output. So forget the other rows. Look at the first row of the output. Look at this row. This row of the output is a linear combination of the first two rows, right? And that's what happens in the product. So you have to take linear combinations of the first row, meaning that you take 1 times the first row in this case, and 1 times the second row, and 0 times the third row. Fine. That's what I just explained, right? This is the A11, this is the A12, this is the A13. A11 times R1, A12 times R2, A13 times R3, add them, get this. Right? Nothing new, nothing new. This is fundamental. Obviously, you can check it also, but second row is what? It is 0 times this row, 1 times this row, 0 times this row. 0, 1, 0. Fine?
Yeah.
Nothing. There is a easier way to say it, but I will say it. हो गया? Okay. So you understand what I have done.
So now that you explain it, I understand it, but when you asked, I wasn't able to figure out
Yeah,
the matrix.
it's
So
fine. It's fine. Yeah. But now you understand that how knowing that interpretation makes this
yes,
convenient.
yes, sir.
Yeah. But you have to remember these things as rules. I mean, it's because you may or may not get comfortable with it in the first time, but you have to remember these things as rules. Okay. So let me write the rule as well as I can. I will try to write it properly. So suppose you are looking at this ... Ri. Okay. I'm trying to write it very abstractly. Okay. And let's say I go from here to, we will do some examples, I think will be good. Ri plus C times Rj. Okay. And nothing else I'm changing. So wait.
You added the ith row, like, right?
I added the jth C times the jth row to the ith row.
Okay.
Yeah, and I think exactly. So for that, I should write that Rj I'm not changing, right? Yeah. Okay. So we will do examples. Don't worry. This one has to get comfortable with this. This is A, and this is my matrix. I will not call it B anymore. I'll call it A prime. You know why? Because this is coming from a change from A. I mean,
Mhm.
right? And then you look at this matrix. This matrix, which is almost the identity matrix, but just that in the just that in the ith row there is a interesting thing. ith row mein aa jao. Ith column is as it is. Okay, but in the jth column also there is a new thing. There is a C. Yeah, we have to do some examples. Don't worry. Maybe sorry. This is should be. Okay. Okay. I have added the. So I've taken this matrix A. I have added the jth row to the ith row. C times the jth row to ith row. Here also I've done the same.
Sir,
Right?
sorry. So what we are trying to achieve is that we are trying to find the row reduction in terms of multiplication, right? Matrix multiplication.
Correct.
Okay.
Exactly.
I was just
Okay.
making sure I didn't deviate.
Yes. Correct. That's correct. So this is also this. Eij is a matrix which has only 1 in ij position, 0 everywhere else. This is the same matrix, right? I mean, just yeah. But you can just think that this matrix, I have just done the same thing as I did to A. I have taken the identity matrix and I've added the ith row, jth C times jth row to ith row. But now, as we discussed, we will do examples on the other side. This thing is equal to A prime product. Okay. Okay. So I take A, I take the jth row and I add it to the ith row, right? And here I take the identity and do that to identity, and multiplication gives me A prime. Okay. So we'll take a break now. 5 minutes. Please join in 5 minutes. Take a break, relax. Take some do examples. Don't try to prove things. Prove it. Do examples. Yeah. Do example.
Yes, sir. Yes, sir.
Okay.